Can you hear me? Is the mic good? Yes. Great. Okay, so data migrations with MagLev. I'm psyched, super excited to be here talking about MagLev. I love Smalltalk, and MagLev is built on Smalltalk, which we'll get to in a second. Let's see. Why is that? There we go. Okay, so quick outline. I'm gonna introduce MagLev, kind of what it is, and then go through some data migration examples and concepts, and then kind of end just with a quick little bit of status and some FAQs on the project. So first, what is MagLev? It is an implementation of Ruby that runs on top of the GemStone S VM, which for most people that doesn't mean much. So what is GemStone S? GemStone S it's a Smalltalk platform that is currently being used. One of their big customers that has been around for quite a while is JP Morgan, that uses GemStone to do their derivatives trading. So it's a platform that can scale, deal with huge data sets, and operate on them really quick. It's used in some of these other areas as well. Still, that doesn't give a whole lot of info. So what is GemStone S? It's a virtual machine that was built kind of from the ground up with native object persistence in mind, caching, and it also gives you some ACID properties. But so GemStone, the first version of GemStone came out in 1986, so 10 years before Ruby or Java, which I've always loved that Ruby and Java are the same age. They both came out in 1996. So GemStone S, it's a virtual machine that's been around for a long time. And just a quick little blurb on why you'd want to use MagLev. As we've seen the quote a couple times from Matt's about we're the masters, computers are slaves. But there's a big focus on writing code and software for people, not for machines. One of the things that MagLev allows you to do is it frees you from having to think like a distributed system or think like a computer, which a big thing is you don't need an object relational mapping layer. You're able to just persist your native objects. Also caching, and thus cache invalidation, which is one of the hard problems, is handled also by the same platform. You don't have to really worry about it. So this really lets you focus on your app and the stuff that you're really worrying about, and less about boilerplate code and a lot of layers of abstraction. So just talk through kind of a typical Rails stack, or just a typical Rails app. So generally on the server, or possibly on other servers, you're going to have a data store, and then often also a memory cache, often memcached, running. Then you're going to spin up your VM. So this could be MRI, it could be JRuby, but you're going to spin up your VM, which is going to load your code, as well as like Active Record, other libraries. After it's loaded that, it's going to log in to the persistence layer, get a connection back, at which point then you can start operating and using this data. So in MagLev, so there's some different terms. MagLev has the concept, a big thing is the stone. The stone is fairly analogous to your data store. That's where all of your data lives. You can think of around the stone, there's a shared page cache. And so the way MagLev works is, so you spin up your client, you spin up your VM. Now the interesting thing, that this is one place where MagLev is very different from any other Ruby implementation. As soon as the process spins up, the first thing it has to do is it needs to log in. So it goes, and once it logs in, the client actually attaches to the shared page cache, which is a big, so this memory is shared amongst all the VMs. So once you've logged in and attached to the shared page cache, Ruby is now available. It's stored in the stone, so as soon as you log in, that becomes available. Another big thing, MagLev, so the fact that it is your persistence layer, most of the concepts that we're familiar with databases are present in MagLev. One thing that's kind of interesting, so your code is always running within a transaction. So with MagLev, you're kind of working with transactional memory. To get a fresh view of the code, there's two ways to do that. One is to do a successful commit. So if you're going to make some changes and you successfully commit, then your code has a fresh view of all of the persisted objects. Another way to get a fresh view is aborting the transaction. And so abort is not the bad guy. Abort is really, it's a way to refresh. When I first started doing this kind of stuff, I felt kind of dirty. It's like, I don't want to abort. Like that, it seems like that's a bad thing. But it's not. In MagLev, it's a common way to get a fresh view of the persisted data. So in this, I'm going to actually go through and try some live demos. We all know, we'll see how they go. So I want to walk through and kind of show just persisting a basic string. And then MagLev lets you persist. We're going to go through persisting a proc. MagLev, you can persist almost anything. There are a few things that don't really make sense to persist. Among those are I/O handles, like it doesn't make sense to persist a socket, as well as like mutexes and semaphores don't make sense to persist. Almost anything else can be persisted. So here we go. So we can fire up an IRB shell. One of the things, MagLev persistence works by reachability. So if you have a persistent object, anything that persistent object references will end up getting persisted. MagLev has a persistent root that is just a Ruby hash that is a convenient place to be able to persist objects. So here we are going to persist a string. So hello world. And then let's see. I'm actually going to also open up another terminal. By the way, can everyone see? Okay. Once we get, okay. So, right now, if we look here at the root, it's still empty. There's two reasons. One is that in this process, we haven't yet committed the change that we've done, that we want to make. So we're going to commit, and then there we go. It's still not available here. Do you guys remember why? We haven't aborted. We haven't got a fresh view of changes that other processes have made. So here we're going to abort, and then take a look at the root. Haha, there's our message. So we persisted a string, which, that alone, there's many other ways to persist strings and share them amongst processes. This, however, is not easily done by many even languages. So we're going to put in a proc.new, and we'll just say hello. We'll just do that. And then over here we're going to commit, and then we can go back to this other VM, abort, take a look at the root, and there's our proc. So over here we can actually call that proc, that's a pretty cool thing. So that's kind of showing the basics of persistence. By the way, as I'm going along, I would love if anyone's got questions at any time.
Okay, so
here we go. I love it.
all right, so your proc, that's good. So what I want to know is, how does At what level does MagLev start doing the chain persistent? When you have a proc there, you didn't instantiate an object in that proc, right? For referencing one, but then know to look through proc to reference it.
Yeah, it will look. It will look through. Sorry, question. Question was, how does it know? How does the reachability work? So if we had in this proc another object that it referenced, would MagLev know to persist that object? So let's go and say, oh, let's see. You know what? There we go. And then let's do our proc puts message. And then we'll commit that. Over here, we're going to abort so we get our fresh view again. And that's actually, you know what? Let's jump into that case in a little bit. So that's actually looking for, let's jump into that a little bit. So that's kind of how some of the persistence works with the built-in stuff. So if we want to have a, let's come back to this real quick. And I'm going to talk about the hat trick. So this is kind of the little demo that Avi Bryant gave when kind of initially showing the world MagLev. So we're going to have a couple classes that we create. We're going to have this hat, and then we're also going to have a rabbit that we create. So we're going to run this code, and so MagLev has, you can see up at the top, there's maglev.persistent do, and then it takes a block. And so this, anytime that you're making code changes, you need to signal, you need to let the VM know this is stuff, these are code changes that I want to be persistent. I'm not just messing with data. So by wrapping the load of the hat and the rabbit in the persistent, sets up in this transaction that all of that code is going to be persistent. So again, if we look out here, if we look, well, obviously we don't have a hat or a rabbit defined. So here we are going to create the hat, which so again ran that code. So that loaded the hat and the rabbit, committed them to the stone, and we now have, if we abort and then take a look at, so actually let's even just look right at the hat. All right. And then we've already kind of seen the magic of we can come back here and put a new rabbit. So .put rabbit .new. Oh, we're not in IRB. So we're going to put a new rabbit in there, commit, abort over here so we get a fresh view. Take a look at the hat, and there's our cute little bunny. So now that is some basics of the MagLev persistence. Now that we kind of have that a little bit out of the way, let's talk about migrations. So with MagLev, you're able to commit just plain Ruby objects to the stone, make them persistent. We are very used to working with kind of dead data, dead objects in a sense. We're very used to having another data store, and like when we go to access a blog, we create an object and then kind of materialize it, grab all of the attributes from the database, put it into that object, and then as soon as we're done, that object goes away. Next time we want to look at that data, we're going to create a new object, do the same thing, pull data in there. With MagLev, your objects are just always there. So we're going to walk through a quick example of a blog. So blog post version 1.0. By the way, this is an example that is in, there's a number of other ones that are in the MagLev repository. So there's a lot of some readmes that walk through kind of the same process we're going to go through. So we're going to create a blog post that has just basic title and text. we're going to write some blog posts that have those attributes and then look at them in a client. So this is just a command line client that's going to print those out. So over here, we're going to go into the blog example. And so we will, there we go. So we will write our blog post, version 1. We're going to commit. Actually, let me go through these files real quick so you can see what we're doing. Okay, so here is, let's see. Can people see that? Great. So this is what, so we're going to create our first version of our blog post that has a, again, title of text. We're going to create an array of these and put that in the persistent root and then commit it. And then we're going to follow that up by really quickly just inserting some blog posts. So rake post 1, write 1, and then client 1. Great. So we've got a bunch of blog posts. Next day, we, whether it's ourselves or our client, we decide, or I mean, kind of see that, okay, title and text is great. It'd be nice to have a date. It'd be nice to know when these things were published. So we're going to update our blog post, add a date instance variable, write some posts, and then look at them in client 2. So we're going to real quick look at these files. So here's the blog post. So you can see we added a date that just defaults to right now. And then write 2 is, again, just going to insert some blogs, including, so this just kind of does a random publication date, but we're going to create some new blog posts. So we will come back out here. We're going to create the second version of our blog post, write some, and then let's take a look at it in the new client, which actually, real quick, the new client is going to include this. It's going to put out the date that they were created on. So we get, once we go to actually display these all of the blog posts, we get this error: undefined method strf time. So we can't format a nil. Like so somewhere we're trying to format it what we think is a date, and if we look at our blog posts, we can see, yeah, definitely those first blog posts do not have a date. So we need to migrate these objects. Okay, so we're going to perform the migration and then look at them in the same client. Let's take a look at this migration real quick. So it is, again, so this is from the docs, but we're gonna create an unknown time. So we're going to create an instance of time, and it's going to override some of the methods to just output that, I mean, we don't know when it was. And then down here on line 17 is where we're going to loop through all the blog posts, and if it doesn't have a date, if the date.nil, we're going to actually just set it to this unknown time. So if we come back out here, we're going to rake migrate 1, and then let's try and looking at it again in the second client that outputs the date. Hooray, no error. So that was able to take those instances, add the new instance variable to them, and then recommit them to the stone. So I'm moving through this a lot quicker than I thought, which might help us get back on time. So this next concept is Smalltalk has a method named become. It is a Spider-Man method, meaning it is incredibly powerful and incredibly dangerous. Like you need to use it correctly. It's kind of like method missing. Method missing is incredibly powerful, but if you abuse it, you end up with code that is hard to debug. Method missing can be very dangerous. Object become swaps the identities of the receiver and the argument. One great use of become is in object migrations. So this is a little contrived. I don't know if you'd really do that, but let's say let's go look at our code again. We want to actually, rather than having the blog post class, we want to actually put it into a module blog and just a class post. And at the same time, we decided that, you know what, we're not going to have text and title. We're actually going to have subject, content, publish that. So we're making enough changes to the object that we don't want to just get into the instances and kind of tweak them. We want to set up our new class, and then we need to walk through the process of pulling our persisted objects and then making them become this new class. So if we look at, here's the second migration. So what we can do is, we've got blog post. We're going to loop through each of those. Here we're going to actually set up the new post. So we're going to create a new instance, and we're just going to pass in the values that we want to carry over. And then this line is what swaps the identities. And again, the reason that in MagLev and kind of in Smalltalk, the reason that you need to do this is we may have persisted objects that have references, numerous references throughout the application that are pointing to specific objects and specific instances. So you can't just do a simple variable swap. That's why, object become lets you really swap out in the object table what they reference. So we're going to come in and we're going to do blog 3. It's not blog 3. Sorry. Yay, live coding. Oh, sorry. Rake post 3, I think, is the. So that's going to, well, yeah, no, so the file is blog post. The rake task is, the naming could be synced up a little better. So that just created the new class. So if we come in here, we can see that we should still have blog post, and we should now have blog and that blog post. However, all of the instances you can see are still the old class. So we can run through, again, we'll look at this migration. So we're going to actually run this migration, and also notice that so here we're going to migrate over to the new class, and then here we're actually going to remove the old class from the system. So let's run rake migrate to, and then we can, so actually we could just do rake inspect. And so you can see here, so now we've got, they're all instances of the new class, and then if we were to look at, so we now know we should no longer have the blog post class. Oh, here we go. So to remind you what we just did, so we renamed the class, changed so set up some new instance variables, and then migrated using object become. And then we looked at the clients, or at the data. So, any other questions? Well, let me quick. So just some info on MagLev. MagLev is a project that was worked on quite a bit a few years ago. The company that created GemStone was acquired by VMware. As soon as VMware acquired GemStone, they stopped development on MagLev, and so it's kind of a little bit frozen in time. We are not yet using MagLev in production. By the end of the year at Creditera, we will have a service that's running in production. So MagLev's not going away. We'll actually be the first company to be using it in a production setting. So it's not going away, but it still has a lot of work to do. Right now, the Ruby version, MagLev runs, it's almost 193 compatible. Thanks to Ryan, who I think stepped out, but Ryan has fixed a number of parser bugs just this year. We were able to extract the parser. The parser used to be part of the closed source GemStone product, but we got that extracted so that people like Ryan are able to help us get MagLev moving forward a little bit. So right now it's 193. There's still some parser bugs that we're going to work through. Another thing to know about MagLev is MagLev itself is open source. The underlying system, so GemStone, is a commercial product. MagLev comes with a community license that really will let you take an application easily up to a medium, possibly even up to like a decently large scale site. The license that MagLev, so the limitations imposed on the MagLev license, one of them is you can have a maximum of 10,000 connected sessions. So you can have your Stone and you're limited to 10,000 connected sessions. The big limitation that scares many people away is you have a 2 gig shared page cache. So you're capped at 2 gig. This ends up not being as big of a deal as it sounds. I know without understanding the whole architecture, it kind of, it can kind of sound like, that's a serious limitation. Really, it's one way of thinking of it is think of your memcached instance that you're running on your servers. It's like limiting that memcached instance to 2 gig. So you can still do quite a bit, but if you're working with massive data sets and you need a single process to be accessing all of the data, the MagLev license, you're going to probably run into some limitations. So the license, it is a commercial product, but the license provided to the MagLev community is very open and will let you be able to develop some decent sized software. Another thing to know is the Stone, so the repository for all of your data was designed to scale vertically. It is not designed to be able to shard out and have running on multiple servers. So obviously companies like JP Morgan, you can imagine their Stone is running on a very beefy, it's a mainframe. So that's like GemStone, it's kind of fun. GemStone will run on virtually every platform except Windows, largely because Windows shared memory is extremely limited. I don't know a ton about it, but from what I know, it's similar to just memory mapping a file. But GemStone is obviously built around the shared memory concept so that you have very light workers that attach to a larger shared memory session. But so that's a good thing to know, that the Stone is designed to scale vertically. Another thing is it's not super easy to get started. There's a lot of documentation that needs to be updated. The current build process definitely needs some work, but we are hoping to continue to make it easier to get into and easier to learn about, really what you're doing. Thanks. I'm glad to be here, and I'd be happy to take any questions. No, so the question is, do you need to know any Smalltalk to use MagLev? No, you do not. If you get kicked out to the low-level debugger, you're at that point, it's not really Smalltalk anyway. It's a program called Topaz, but you don't need to know any Smalltalk to get started with MagLev. Question is, how long did it take before I stopped thinking about commit and abort? And that you actually, in getting into MagLev, commit and abort, you actually get really familiar with. You use them quite a bit. So one thing with MagLev, it's not that you get to forget about persistence. It's just you think about it in a different way. The big thing is that you're removing the layer of mapping all of your objects down to database tables and attributes. You can just work with objects, but the process of deciding what should be persisted when, like when to do validation, you still need to deal with all of that. Great. So the question is, how do you deal with commit conflicts? So MagLev handles that. So if you had two gems, so say even in the demo that we were persisting a string, if you had one gem that added it to the root under the keyed message, and then committed, and you had another VM that when that VM goes to add it to the same key and commit, you will get a commit failed exception, which you can actually inspect that exception and it'll have a list of reasons that it failed. But if you go to commit, MagLev will raise an exception. And so one of the interesting things is you're in charge of a lot of properties that are often handled by the database layer, like resolving commit conflicts. It's something that's normally done by the database and you're not really aware of it. But in MagLev, it's kind of bubbles up and you're aware of those levels. It is. Yep. So the question was dealing with specific objects. So when you persist an object and then you pull it back out, is it the same object? So yes, it is. It has the same object ID. So that's one of the things that helps MagLev and GemStone operate very quickly is an object's representation is the exact same in memory, on the shared page cache, or in the stone. And so moving an object between is just a byte copy. So you're dealing with the same objects. Any other questions? All right. Thank you very much.